Morning, good afternoon, good evening. Hello, everybody. This is Adrian, your host, and we will get started in just a minute. All right, here we go. Hey, everyone. My name is Adrian Goins. I'm going to do something crazy today. I'm going to, let's see if this actually works. Hey, it's a webcam. We'll see if this totally crushes my bandwidth. I'm a little, my head's a little cut off. I don't normally do this. I live in the middle of South America. Well, actually, that's not true. I live in the middle of Chile, which is in the south part of South America, and I am constantly fighting with bandwidth with my internet provider. I do live streams and stuff like that, and well, whatever. So let's see how this goes. So that's me. Well, this is me. Probably at some point throughout this, I'm going to totally forget that my webcam is on, and I'm going to pick my nose or something like that. My name is Adrian Goins. I'm the Director of Community and Evangelism at Rancher Labs. There's lots of ways to contact me. None of them are important. We have so much stuff to do. We're just going to go right past this slide. But if you do want to tweet about this, tweet with the hashtags Rancher Training and Rancher K8s. So we have a bunch of stuff to go through. I always run late. I always say I won't run late, and I always run late. And so anyway, we're going to do some intro and housekeeping stuff. We are going to install K3s. We are going to go through Kubernetes and customize on the command line. Then we're going to install Rancher, and we're going to repeat some of the stuff that we did, but on the Rancher side of things, and I'll give you a whirlwind tour of the Rancher interface and the cool stuff that you can do with it. And then, well, if there's any questions that are remaining, we'll answer those too. There's a little news thingy scrolling across the bottom of the screen there, so that's got information for you. I hope you understand basic container concepts. If you don't, if you thought this was like a cooking class or something, hang out anyway, because you'll learn some cool stuff. There's another news scroller out. In fact, I will switch to that now. There is a repo for everything I'm doing today. I literally have the README open and I just copy and paste from it so that I can provide a consistent training every single week that I do this. But you can also follow along. So, you'll get the copy of the slides and a link to the video after everything is over. Grab this now. Otherwise, I'll keep that little scroller up there on the bottom. And yeah, Rancher has tremendous documentation. When you need to know how to do something, go there. We spend a lot of time on our docs, and while they're not perfect, it's a work in progress forever because the product is constantly evolving, they're fantastic. So you'll find most of your questions answered there. Otherwise, we have two community support channels. We have the Rancher users Slack, and if you don't have an invitation for that, you can go to slack.rancher.io and get an invitation. Or if you just go there, there's a link that says go sign in, or you can go to rancher-users.slack.com. I don't actually even know the link. So just go to slack.rancher.io and you'll figure it out from there. Slack is great. We have something like 20,000 people registered in the Rancher user Slack. There's thousands of people online at any given time. There's channels for all of the various things. So that's great if you want to find community support for something now. If you want to find stuff that people asked and answered that lives for longer than things do in Slack, then check out the forums, forums.rancher.com. The forums are also useful because every month I run an office hours session. I run two of them, one for the Americas and one for EMEA, which is Europe, Middle East, and Africa. And I pull questions from the forums and from Stack Overflow to answer live during the office hours sessions. So if you do post something there, you can also find me on the Rancher user Slack. You can just ping me and say, hey, here's a question. Can you answer it? We might answer it. We might pull it for office hours. There's lots of stuff available. Somebody yelled at me last week because that news crawler blocks the bottom of this slide. So I'm going to turn it off for the next two slides. People join this class who don't actually know anything about Rancher. Let me just scroll. Okay. So if you'll give me a couple of moments, I will tell you about Rancher. And I'm actually going to read the notes, so I'm going to be looking over here. There are two key pillars of a successful Kubernetes strategy. Rancher has overseen and participated in the deployment of tens of thousands of Kubernetes clusters. And throughout all of this, we've identified that to be successful with Kubernetes, you need to have these two pillars, and that's certified Kubernetes distributions and a centralized management layer. For certified Kubernetes distributions, I'm just going to go to the next slide because it's faster. We have two of them. We have RKE, the Rancher Kubernetes engine, which is Kubernetes packaged inside of Docker containers that makes it very, very portable. Unlike most Kubernetes installations where you need to do a bunch of stuff to prep the host before you can join the cluster, with RKE, you just need a supported version of Docker. It's great, but it contains all of Kubernetes. And if you're deploying out in a cloud, for example, in AWS, you don't necessarily need all of the Azure plugins or the GKE plugins, or if you're on-prem, you don't need any of that. So to solve that problem, we created K3s. K3s is still upstream Kubernetes, but all of that stuff that's in there has been made optional. You can add it back in, but it's not installed by default. The result is that it's a super, super tiny, super fast version of Kubernetes that runs really great in resource-constrained environments. We also work with any certified Kubernetes distribution. And in fact, if you're new to Kubernetes, we recommend that you look at using a hosted provider solution like EKS, AKS, GKE, DigitalOcean solution, anything where you don't have to worry about the control plane. Because in the beginning, when you're learning how to do this stuff, you want somebody else to deal with that so that you can just use the Kubernetes bits. Once you have a certified Kubernetes distribution installed, then you need something to do the heavy lifting of managing it so that you can focus on using it. That's our main product, which is Rancher. Rancher is the most widely adopted Kubernetes management solution. It has over 100 million downloads. We have over 30,000 deployments that we know about, and it's 100% free and open source, like 100%. So everything that you see me doing today, you can do. All of our stuff is totally free and totally open source. RKE, K3s, Rancher, everything. Rancher does simplified cluster operations and infrastructure management, including provisioning, version management, visibility and diagnostics, monitoring and alerting, and centralized auditing. For security policy and user management, you can automate processes and apply a consistent set of user access and security policies for all of your clusters, no matter where they're running. It's a multi-cluster management solution. And for shared tools and services, it provides a rich ecosystem of services from a catalog that you can use to build, deploy, and scale containerized applications, and provide day two operations like app packaging, CI/CD, logging, monitoring, service mesh, backup, and so on. Once you have these two pillars set, you can do anything on top of it and you'll be successful. We are building an application deployment engine for Kubernetes called Rio. It's still super alpha. I keep saying I'll take it off this slide, but whatever. And you don't even have to use our stuff to get here. As long as you have a certified Kubernetes distribution and a management layer, you are free to explore and run around and play and reduce the cognitive load associated with learning all of this stuff. So let's jump into K3s. I'll throw that resources thing up there just in case you missed the download URL for the repo. CNCF certified, super lightweight, production quality. It's not just suited for edge and resource constrained environments. You can run it anywhere. You can run it in the data center if you want, and lots of people do. It is amazing. Our installation process has you actually installing it by just dropping the binary on a host and then setting up a server or an agent. But Alex Ellis, who's the guy behind OpenFast and Inlets and Arcade and some other open source stuff that's super cool, created an installation tool called Ketchup that allows you to install K3s over SSH. And that's what we're going to go do right now. Check the questions. Okay, everybody still says audio is fine. That's good. Ketchup, install, give it the IP, tell it what user you want to connect as, and Ketchup binaries are bundled with, they're not bundled with a version of K3s, but they're bundled to install a specific version of K3s, but K3s and Ketchup move at different speeds. So if you want to install a different version of K3s, you just have to pass K3s version. And there's a bunch of other flags that you can pass to it as well. You can look in the help for it. In less than a minute, in fact, faster because I already have the K3s binary downloaded on the machine where we're installing this, we'll spin up a single node Kubernetes cluster, and it will bring back the kube-config file. The way that you interact with Kubernetes is via a command called kubectl or kubecontrol or kubectl or whatever. How you say it doesn't matter. This printed it to the screen, but it also saved it as a file. So I'm just going to set, now I'll close that little thing there. So I will just set the environment variable kubeconfig to the location of that file. And then whenever I first install a cluster or change the kubeconfig, I like to make sure that I'm talking to the right cluster by running kubectl get nodes. Now, somebody probably noticed that set-x kubeconfig is not how you would do it in bash. I use fish. If you're using bash, it's actually export kubeconfig equals ptb slash kubeconfig, something like that. I think that's right. So if you use bash, there you go. However, just get it in there. And that's it. We've got a Kubernetes cluster. It took longer for me to tell you about it than it did to actually do it. So now what do we do with it? Kubernetes. I used to say Kubernetes has a learning curve close to vertical. But that was when I didn't really know much about it. I was just complaining because it was difficult for me to learn. I've since learned much about Kubernetes, but more importantly, I've learned much about learning. If you see me in any of my videos or any other trainings that I do, I believe that we should always be learning. Keep learning. If you tell yourself that something is difficult, your brain will accept that that's the truth, and it will make it harder for you to do it. So I'm here to tell you that Kubernetes is easy. Some of you are probably like, no, you're totally lying to us. Kubernetes actually is. At the core of Kubernetes, all you need to know are these things. It just takes blocks and assembles them into applications. You have pods, replica sets, deployments, config maps, services, and ingresses. You have other stuff, but these things are all you need to know to spin up applications. Once you understand these, and by the end of this class you will, you are then free to do stuff and to learn about other things as you need them. Persistent storage, service mesh, resource limits and requests, things like that. But all of it comes from this core. Let's start with a pod. A pod is the smallest unit of thing, smallest object that you can deploy inside of a Kubernetes cluster. Pod is usually the first place where people freak out because you know about containers. A pod is a logical grouping of one or more containers into a unit. That unit shares network space, storage space, and some other stuff that we don't talk about in this class because it's just not important. This allows them to be scheduled together. And the coolest thing is that it enables you to run one service, one process per container, which is a best practice. And those things can still talk to each other on localhost. So web server and fast CGI server, or something like this, where you might have a CMS that pulls content from somewhere and saves it to a disk. And then there's a web server that takes that content and serves it out to consumers when they request it. This is a good representation of a pod. Together, these two containers provide a function. And when you need more horsepower for your application, you're going to scale this up because they're a unit and they want to be together, and you might need 1, 2, 5, 10 of them. Much of the time, you will have one container per pod, and that's totally fine. You don't need to put multiple containers in there. It's just when you do, you can. And isn't that great? Because the unit is what you're scaling, they're called replicas as well. So you're going to scale up multiple replicas. You wouldn't put things together that don't need to scale together. Like you wouldn't put a web server and a database server, because when you need more databases, when you need more webs, you don't need more databases. And that's a terrible example because the database containers wouldn't be able to talk to each other. But you understand, like I said that and you're like, oh, that makes no sense at all. That means you get it. Everything in Kubernetes happens with a manifest, and a manifest is written in YAML. This is the next place where people freak out because they start to see the complexity of this YAML and they're like, I'm never gonna remember how to do that. And that's cool because you don't have to. There are tools that generate YAML for you, and we'll talk about some of those today, but it's important that you understand what a thing is before you start deciding to use shortcuts to generate the thing. Here we go. 4 top-level keys: API version, kind, metadata, and spec. API version tells Kubernetes where in its API definition it can find information about how to make whatever the thing is that you're asking it to make. In this case, that's the kind. It's a pod. Metadata we'll talk about in a little bit. Spec is the definition of the thing. Spec differs depending on what it is that you're creating. In the case of a pod, there's a key for containers, and underneath that is a list. The list can be 1 or more containers. In this example, we have 1. Its name is my app container. Its image is busybox. And for a pod, that's really all you need. It just needs to have a name and an image. But we're also going to override the command to echo hello Kubernetes, sleep for a second, and then exit. Okay? If we jump over and run this now, I want you to think, what's going to happen when this pod exits? We apply things to the cluster with kubectl apply. We use -f and we point it at a file. If I were to show you that file, it's just the same thing that I had on the screen a second ago. Now we want to see into the cluster. And for that, we're going to use kubectl get pods. I could type pods. You can also just type po. You're going to type these commands so much that you're going to use the abbreviations that exist, or you're going to create your own shortcuts like kgpo. I used to just use the shortcuts, but I would forget to turn them on for class, and I'd be teaching people new things, and they're like, what's kgpo? And I'm like, oh. So now I have a thing that actually I get to type the shortcut, but it expands it automatically so you can see the actual command. If I run kubectl get pods, oh no, there's an error. We can actually provide -w and it will stay connected, and then when the state of the object changes, it'll post updates. What happened, we didn't get to see it because I was talking. Okay, there we go, running, completed, and it's gonna go crash loop back off again. Unless you tell Kubernetes that the thing that you just told it to run is going to run once and then exit, Kubernetes expects that it's going to continue running. So when it exits, Kubernetes restarts it, and then it exited. Kubernetes restarted it, and then it exited, and Kubernetes restarted it. Kubernetes doesn't know that we told it to exit. It just says, well, shoot, I need to restart this. But after a while, it figures out, okay, clearly there's a problem, and it takes a lot of resources to start a thing, and so I'm not going to keep restarting it because obviously it's broken. I'm going to wait. I'll wait for 2 seconds, and I'll restart it. Ah, it crashed again. I'm going to wait for 4 seconds. Oh, okay, now I'm going to restart it. It crashed again. I'm going to wait for 8 seconds. That's a crash loop back off. There are back off timers all throughout Kubernetes where it says, I'm going to either wait for this thing to figure out what its problem is, whatever it's waiting for, a database or a cache, or I don't know, or I'm going to wait for a human to come along and recognize that this is totally broken and fix it. It will continue to increase that back off timer up to 10 minutes between restarts before it starts over at 0 and it continues going. Hopefully by then somebody's figured it out. We could actually run kubectl get logs. Oh, sorry, kubectl logs. We could run kubectl logs, and you would see that the pod has been outputting hello Kubernetes right before it died. Yay, it did what we told it to do. Let's delete that with kubectl delete pod myapp -pod. Bam, gone. What we just did, okay, yeah, it's cool. You're going to see lots of different ways to do things today. But from the beginning, I want you to think about doing things in a way that's declarative and repeatable. All this means is if I do something on a cluster, I make some change, I push something out, I change some config, whatever, and then I leave and I go on vacation. And I'm on a liveaboard dive trip on a sailboat in the middle of the South Pacific and nobody can find me. And the cluster crashes. My coworkers don't know what I did. And it's harder for them to figure out what's wrong or to restore it to a known state. It's far better if we can use a tool such that I'm not making changes, but instead I'm updating some central source of truth and it is responsible for making changes. This is easy when you're using it with servers or systems or hosts or whatever. It's like Terraform or Ansible or Puppet or Chef or whatever. There wasn't really any good for Kubernetes until somebody created Kustomize. Kustomize allows you to take those manifests and turn them into templates and keep those templates in source control. Kustomize was built into kube control back in 1.14 because it's just awesome. And if you want to know more about it, you can go to kustomize.io. And for the rest of today, I'm going to show you how to do things directly with manifests, how to change things in a bunch of different ways, and also introduce you to Kustomize. Not so that you have to go and learn it right now, but so that you know that it's out there and you can start to think about using something like this from the beginning. It's a lot harder to retrain yourself later after you've picked up bad habits. Ask me how I know. There's going to be a recurring theme throughout the class, me showing you different ways to do stuff. Somebody once complained that I make it too complicated. I should just show you one way, and I totally disagree. When I buy a book, you buy like those O'Reilly books or the, I forget the other ones, the guys that make those like giant textbooks on how to do something. The first thing I do is I look at the table of contents and the index. If the index is written in big print, I know that there's not a lot of information in the book. I don't buy the book. If the index is in super, super tiny print and also several pages long, I know that there's a lot of information, a lot of different concepts in the book. So that tells me right away the value of the book. And then I'll skim through both of them to see what things it covers so that from the beginning, I know what the capability is of the thing that I'm learning and if the book contains information on it. Then as I'm learning a thing and I'm like, oh, it would be really nice if it did such and such, I remember, oh, that was in the index. Let me go look up how to do that. I never read books straight through from front to back unless they're fiction, because try reading a fiction book all over the place. But nonfiction stuff or training manuals or whatever, I just read what I need to know to learn the thing that I need to know right now. So that's what you're going to get today. You're never going to create pods, at least not like we just did, because by themselves, they don't give you any really good interface for interacting with them. Instead, there's a thing that is responsible for managing pods, and that's called a replica set, which you're also not going to create. You're going to create deployments, but a deployment creates a replica set, and a replica set creates a pod or a set of pods. So you need to just understand what a replica set is, and there it is. It's written on the screen for you. But it introduces the concept of state management inside of Kubernetes. This is different from stateful and stateless, which we also talk about in a minute. Kubernetes understands two states, the actual state and the desired state. And it forever works to make sure that those two are reconciled. Here we have 3 hosts, 12 replicas. Let's just pretend that they're all from the same pod definition. The actual state is 12. The desired state is 12. But when one of those hosts dies, well, now the actual state is 8, which is different from the desired state of 12. So Kubernetes does whatever it has to do to reconcile the two states. And it does this by launching 4 more pods and putting them somewhere. That's it. That's state management. Congratulations. You know what Kubernetes does. Anytime we make a change, we are not adjusting the actual state. We are telling Kubernetes the new desired state. And we don't ever tell Kubernetes how to do its job. We give it rules, we give it guidelines, we give it suggestions. We say, okay, these hosts over here should only get things with this tag because they have really fast SSD disks, but these hosts over here, they cost less money, so you can put anything over there that you want. But as far as where those things go, Kubernetes makes decisions. It's one of the more advanced subjects, so that's all you're going to get about it today. Deployments. We're going to spend a fair bit of time here because this is actually where you're going to spend most of your time in your Kubernetes career. A deployment creates a replica set so that a replica set can create some pods. But a deployment, well, a deployment, okay. Kubernetes uses things called controllers. Controllers do things. So a deployment controller creates, that's right, deployments. Deployments are for stateless applications like HTTP. HTTP doesn't care who you are. It has no idea who you are. From one moment to the next, it's like, hi, I'm Tom. It doesn't matter which pod your traffic lands on. It doesn't matter if a pod gets deleted and the traffic lands on a different one. It just doesn't matter. If you have something where it doesn't matter, and if you're not familiar with stateless HTTP and you're like, but how do shopping carts work? Dude, without things like Redis and session keys and stuff like that, none of that stuff would be possible. HTTP is just as dumb of an application as it gets. So it doesn't matter. Stateless, easy. But if you have something where it does matter, for example, a database that has a primary and two replicas, well, it matters where the primary is, what storage it is, what its name is, what IP it has, that it comes up first, that the replicas can find it, and so on. If it matters, you have a stateful application, which is handled in Kubernetes by a stateful set. I think the controller is called a stateful controller, but I'm not sure because whatever. Doesn't benefit my life to know. I just know that stateful sets exist. There are also daemon sets, which create one replica on every single host. So one copy of a pod on every host. If you have 3 hosts, you launch a daemon set, you get 3 pods. You add a 4th host, bow, you get a 4th pod. Okay, they're great for things that use standalone resources, like if everything has to listen on port 80. You can't have all of those bundled up on one host because there's only one port 80, so you put them on all the hosts. Daemon set. There's also a job, which is kind of like what we launched in the beginning, where it's going to do something and then exit and Kubernetes won't restart it. And if you wish to schedule jobs to start on an interval or on a schedule, that's redundant, you would use a cron job, which is exactly what it sounds like if you've done anything with Linux. So a cron job starts jobs on a schedule, they run, they exit. Kubernetes is like, cool, did your thing. Good for batches. There's also ingress controllers, which we'll talk about later on, and there's a bunch of other stuff. So today, deployments, stateless applications, deployment controllers. One of the things that they give you is the ability to do rolling updates of your application. So here we have an application, 4 pods, running version 1.0. 1.1 comes out, and we tell Kubernetes, hey, our desired state is that we're running version 1.0. Kubernetes is like, sweet, I will spin up some 1.1 pods, and then I will kill off some of those 1.0 pods, and then I'll spin up some more new ones, and I'll kill off some old ones, and there you are, sir. You are now running version 1.1 of your application. Yeah. And if something goes totally sideways, because we did it through the deployment interface, we have the ability to roll back. In fact, you can roll back to any previous state that exists for the particular deployment that you're working with. That's a good thing. I told you, there's many ways you can do things in Kubernetes. For example, kubectl, create a deployment called Nginx, and we want this to run the Nginx 1.16 Alpine image. That's all you need to create a deployment. And we can do that. Kubernetes says, okay. We can run kubectl get deploy, and you see that it's in the process of building. We can say get replica set, not that we care, but just so you know I wasn't lying to you, there's a replica set. And we run kubectl get pods, and you see that there's a pod. Now note the naming reference. Nginx is the deployment. The replica set is Nginx dash some stuff, and the pod is Nginx dash some stuff dash some other stuff. We can do things like scale. Let's go to 3 replicas. And now when we run kubectl get pods, hey, looky there. We have 3 replicas, but note now that the names, deployment dash replica set dash, and then a unique identifier for the particular pod. Okay, let's delete that. I love the whole cloud computing thing where you're like, create, delete. I don't like you. I'm going to delete you. It's so liberating. We don't have to be attached to any of these things. We can recreate them and they will come up exactly the same way. So we just nuked that. What if we weren't ready to apply the manifest, but we wanted a template so we could get started? Well, you can you can run the same command with, all right, so dry run equals client is the latest version of kubectl 1.18. They changed the syntax. You used to be able to just say -- dry run. So if you type dry run equals client and kubectl spits back an error at you, just erase the equals client part or upgrade your kube control, because that's actually the problem. So we run dry run equals client, and then we say -o YAML, and when we press the enter button, it generates the manifest that it would have applied to the cluster, but instead of applying it, it shows it to us. We could save that to a file, we could go in, we could edit it, and then we can apply it later, or we can commit it to a source code repository and do a bunch of stuff that way. Let's do this with Kustomize so you can start to see the benefits. If you've checked out the repo, we have a directory called deployment, inside of which we have a directory called base and another directory called overlay. Inside of the base directory, we have deployment.yaml, which is basically the same deployment that we just launched a second ago, 1.16 Alpine, but it's got a little bit of other stuff in there that we'll talk about later on. There's also a file called customization.yaml. When you use kubectl apply -k, you're telling kube control to look in, you pass it a directory. You say, go look in that directory, and there's a customization.yaml file in there, and go do what it says. In this case, it says, these are 2 resource files, deploy them. And then it says, make a config map from this file here and call it index. Go and do. And it'll go and do that. So we say kubectl apply -k dot. And it says, okay, sweet. I created a deployment. I created a service. We haven't talked about services yet. Don't freak out. And I created a config map. But notice the name of the config map. It's not just index. It's index dash some unique identifier. That's going to be important in a few minutes. All right, cool. So we're kind of in the same place we were. We have a deployment. You can just skip. I'm going to stop talking about replica sets. You have a deployment. You have some pods. Replica set just sits in between like a fifth wheel or chaperone or whatever. You get the joke. Okay, so doing stuff with Kustomize. All right, well, now what can we do with this? What was that thing called? KGPO. We can look at the YAML for anything that's running in a Kubernetes cluster by saying kubectl get thing -o YAML. So get me the pod called blah blah blah, and it's going to actually send back a whole bunch of stuff. So we're going to pipe that to less. Boom! We get back the actual information for what is running in the cluster. It looks very much like the manifest that we deployed. It has some extra information in there because, whoa, wrong button. Has some extra information in there because there are defaults that you don't need to put in the manifest, but they do show up in the running manifest, so it's whatever. And then there's like this status thing. So that's cool. What else can we do with the deployments? We can upgrade the image. So let's say we don't want to run 1.16 anymore, we want to run 1.17. So we say kubectl set image deploy nginx, and then even though there's only one container, we still have to tell it which container we want to upgrade. It happens to be called nginx, and we say 1.17 alpine. You can watch updates happen with kubectl rollout status, and then the deployment that you want to watch. It will sit here and it will tell you when things get updated. The idea being that eventually you'll notice that this is taking a really long time. I wonder what's wrong. Let's start by looking at the pod. Oh, we have an error. Error image pull. Let's pretend we don't know what that means. How do we find out? Well, I already showed you how you can look at the YAML itself, but that's the object. That's like, opening the object up and like looking inside of it. What you want to see is how does Kubernetes understand the object from the outside? And for that, we run kubectl describe. kubectl describe is used to look at an object from Kubernetes' perspective, and it gives you much of the same information, but at the bottom, it gives you a section called events. Events are everything that has happened to this particular object since it was born. So you can see that it was successfully assigned. Totally lost my mouse again. There it is. Successfully assigned. Okay. Oh, failed to pull image. Okay, we've got an error message here that says, it says I misspelled the name. Huh. Okay. But notice, right now, the original pod is still running. If we had 5 replicas and this was our production website or whatever, it's still up. Customers are still visiting it. People are still buying things. Our boss is not mad at us. We are totally not going to get fired. So we have the time to troubleshoot what's wrong and fix it. In this case, we know my mistake. So let's just undo the rollout. And let's change it differently. We're not going to change it with a customized template. We'll do that in a second. I want to introduce you to kubectl edit. Remember, I'm just showing you lots of different ways to do things. I'm not telling you one is better than the other, or one is right and one is wrong. Whatever works for you is the one that works for you. You can edit any running object inside of the Kubernetes cluster with kubectl edit and then whatever the thing is. Now we could go and we could edit the pod directly, but the pod is controlled by the replica set and the deployment. So if that pod were to get deleted, our changes would be lost and the deployment would deploy something according to the spec that's in the deployment. In fact, let's look at that really quick. This is the deployment manifest. API version, kind, metadata, and spec. There you go. Spec is interesting. Here we want one replica. And if you look under template, you see that, well, there's another metadata and there's another spec. And this from here down looks very much like that pod that we launched in the very beginning. There's a containers thing, there's a list, and there's a bunch of other stuff. Well, you're absolutely right. And this is also why I just skip over replica sets whenever I'm thinking about this stuff. The deployment is responsible for deploying pods, ultimately. So the definition of the pod is in the spec. Deployment creates a replica set creates a pod, and I've told you that the replica set babysits the pods and the deployment babysits the replica set, but how do they know? I mean, the name shows it, but that's really for our benefit because we're humans. Computers do things better than us. It happens with what's called a selector, and this is where you get metadata. Let's start with the metadata for the deployment. Everything just needs to have a name, bare minimum name, but they can also have labels. And these are arbitrary key value pairs that are used for whatever you want. It's good to have enough labels on a thing that you can uniquely identify that thing. So commonly used is app and then whatever the app is. There's also environment. It could be like development, staging, production. There can be lots of things, whatever you want. Notice down here that in the template for the pod, we have the same metadata. Also a best practice to have the same labels on things that are related to one another. So your deployment should have the same set of labels as, well, it's going to have whatever for the replica set and for the pods. But up here, you see we have a selector. The selector says match labels, and then it says app is nginx. So the deployment knows that it's responsible for anything that has the label app is nginx. And the replica set that it creates is the same thing. The pods have that label, and suddenly that's how the replica set knows what it cares about. Also, not really very difficult, but there you go. Welcome to metadata. We will edit the deployment. Oh, wow, that's a lot of stuff that we don't care about. Annotations are another form of metadata. We'll touch on those briefly when we get to ingresses. Again, like, don't freak out. All of this is just a key kubectl last applied configuration, and then this is the actual manifest for the last applied configuration, which is kind of cool. That's how it knows what it can roll back to and some other stuff. What we care about is down here under image. Where is that? There it is. Let's just change 116 to 117. And now you'll see that it's going to install in a second. We could actually do kubectl rollout status, but probably by the time I get that typed, rollout status, it's probably going to be done. Oh, yeah, see. Ta-da! Successfully rolled out. If we wanted to roll back, what do we use? kubectl rollout, undo. And now it's in the process of rolling itself back. It's easy. It's easy. It's so easy. All right. I think all of you are like on the edge of your seats, either that or everybody left the class. So we got 35 people here. Okay, we only have one question so far, so hopefully I'm doing a good job. Justin asks if it only understands YAML or if other file configuration formats are understood. It understands YAML and JSON. JSON is a subset of YAML, or YAML is a subset of JSON. Somehow they're related. I don't know. I do all my stuff in YAML because most of the examples that you'll find online are in YAML. So if you start converting it to other stuff, you're just going to create more work for yourself. But if you don't care, or if you super hate YAML, there are other tools. For example, there's a tool created by the Grafana people called like Tanka or Tanaka or something like that that uses JSON it. And I don't know if you're into that. You know, it's supposed to be easier to use. I actually looked at it last night and I was like, I'm not learning that. So yeah, there are other options and other tools to do stuff. They do translations. Trick says JSON is much less forgiving than YAML. YAML has comments. That's true. If you want to get into commenting your stuff so you can remember why you did something, YAML's going to help you out there. But is there a kubectl redo? Oh, what an interesting question, Trix. No, when you roll back, it's like a pointer. And so it's actually, you can't also roll forward. To roll forward, you would need to reapply the whatever change you had make. And the reason for that is, you know, you can have like a stack and you can come all the way back to here and then you could like go sideways. They're not like snapshots where you can restore to a particular one. It reverts or it goes back. It does a diff between the current config and the config at the time that you want to roll back to, and then it applies that diff. So it's actually rolling forward by applying a diff from a previous config. Good questions. All right. How are we doing on time? Not bad. So you deploy an Nginx container. Comes with a default Nginx configuration file that is totally not useful for anything that you want to do. So how do you solve this? Do you extend the container and then like roll a new one, you know, from blah, 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 and then you add your config to it? You could, but now you got to keep track of when upstream changes. You're always rolling updates, and if you don't like a config change, bleh. Another way that we used to do it is you would attach a volume to it. So like an NFS share, and you would attach that to all your Apache or Nginx containers, and it would have all your configs, and that works. You can make the changes and bounce your containers, but that's a fragile thing, particularly if you're using NFS. Otherwise, if you're doing it with regular volumes, you have lots more stuff to update. It's just bleh. Kubernetes solves this with a thing called a config map. A config map is a separate resource that has key value pairs. And you attach this to a pod, and all replicas get the thing, and you can have those key value pairs appear inside of the container in one of various ways. Environment variables, where the variable name is the key and the value is the value. You can have it override files, where the file name is the key and the value is the value, the contents are the value. Or you can have it override an entire directory where each key in the config map becomes a file in the directory with the contents being the values. What's cool about config maps is they're handled independently from the containers and the pods, and they're attached by Kubernetes. So you can update your config map and it will update in real time inside of your containers. And It doesn't necessarily reload your application, but if your application is smart enough to detect those differences, it can do dynamic reloads on the fly without you having to go in and shoot pods in the head. The Nginx ingress controller, for example, we'll talk about him in a second, does this. So you can make changes to its config maps and it just does dynamic reloads. Here we have one of two paths that you can follow. Whichever one you follow is up to you. The dynamic reloading is cool, and that's the default for Kubernetes. The customized side of the fence, the declarative and repeatable with the Git repository as the source of truth, that side of the fence says that if I have the ability to update config maps on the fly, then technically I'm changing the runtime operation of the containers, not in a repeatable fashion. It's possible that there could be a container running with a change that isn't reflected in the ultimate source that was used to launch that pod. And so that's bad, that's a fail. For that reason, the default behavior of Kustomize is to create config maps with that little extra identifier at the end. And then if you change the config map and you apply it with Kustomize, it updates the deployment manifest with the new config map, and it actually does a rolling update of your pods. Which one you go for is entirely up to you. If you prefer to do the in-place config map updates, you can tell Kustomize just not to make special file names. Just use the generic ones. Let's really quick just look at config maps, just so you can see what I have created, and then, yeah. Oop. My cursor keeps being in the wrong place. I need focus follows eyes, like the thing that you look at, that's the thing that comes to the foreground. Like focus follows mouse is cool, focus follows eyes. All right, we have a config map called index-blah-blah-blah. You don't need the slash. Sometimes I put the slash, sometimes I put a space, whatever. Oh, I want -o YAML. Okay, ignoring all of the metadata down at the bottom, you can see that it just has, so API, metadata, kind, and instead of spec, it has data. And data has a key, and then this little pipe symbol when used with a config map means that the value is a multi-line value. So here's a multi-line value for the key index.html. And if we look at the deployment, if I scroll down to the bottom, you see that we have volumes. Create a volume with the name index and use the config map that also has the name index as the contents of that volume. So it's going to create like a disk, and the value of the disk is going to, the contents of the disk will be whatever is in this config map. And then up here in volume mounts for the container, I say take the volume called index and mount it at user share nginx HTML index of HTML. And because we're doing just a single file, you also have to say subpath with the file name. Don't get bogged down in that. It's just how you have to do it if you don't want it to mount the config map as a directory. The result is the contents of that config map show up as the file index.html. And for our default environment, that's just an HTML file that says hello from nowhere. This is the default environment. Now I've shown you Kustomize, but I haven't shown you what it can do. At this point, it just looks like it's making more work for you. So let's take a step back and imagine that we're responsible for a Kubernetes cluster that runs development, production, and staging environments. They're really basically the same thing, slight variations between them according to the version of the application that we want to run and perhaps how many replicas. If we come back up, remember there was that overlay directory? And inside of there, I have a staging directory and a production directory. Inside of the staging directory, there is customization.yaml. You want to know what it's going to do? That's the file that you look at. And here we have some additional information. Name prefix, everything is going to get prefixed with staging dash. Common labels, everything is also going to get a label of environment is staging. it will start from the base configuration in that directory, which is where we were just hanging out a second ago, and it's going to patch the contents of that directory with these files in this directory. We'll look at those in a second. It's going to generate its own config map, replacing the one that is in the base with the file in this directory. That file looks like that. It says, hello from staging. Our image is patched to run Nginx 1.17 Alpine instead of 1.16. And let me make sure I didn't, okay. So we're still running, make sure I didn't change the deployment.yaml. Yeah, so the base one still runs 1.16. The staging environment, a little more cutting edge, we're gonna run 1.17. And we only want one replica. If we go over to production, customization.yaml has its own set of similar things for the production environment. Here, we're going to run 1.16.alpine because production is a little bit more conservative. It stays one version back. And it says hello from production. Oop, wrong one. Replica count. And it runs 3 replicas. Having defined all of that, you understand, you can see how it's a template. There's base, that's where we make most of the changes, and then we just make patches for the other environments that we want to deploy. We can now say kubectl apply -k staging, and blam, we got a staging environment. And we can say the same thing for production, and blam, we got a production environment. You like that? Blam. I don't know why I have sound effects today. kubectl get deploy, and you see that we have our original deployment, which actually, let's delete that because we would never actually deploy the base. That's just the base of the template. Base. The tab completion defaults to looking at the cluster for the thing instead of looking at the directory. So that was a pause just because I hit tab. So let's just delete the base. Okay, now we run kubectl get deploy. And you see we have staging and production. Staging has 1 replica, production has 3 replicas, and I could go and show you the config maps, but just trust me that they're what I said that they are. They're what I showed you. So now we have these staging environments and the production environment that nobody can talk to. Isn't that awesome? No, it's not awesome. If any of you said, yes, it's awesome, you work in a bank. We need to expose those services, those resources to the internet or outside of the cluster. I don't care whether it's the intranet, the LAN, whatever. We need to expose them outside of their little reserved things. Pods have IP addresses, but you'll never talk to the IP of a pod because you don't know if it's going to be there. You don't know if it's going to get deleted and show up somewhere else. You don't know if something else is going to get launched later and have that IP. You can't trust pods. Services. Create a stable DNS name and a stable IP address inside of the cluster, and they route traffic to a bunch of pods using selectors that you already learned about. They're essentially layer 4 load balancers. I call them dumb load balancers, not because they're dumb, but because they don't make decisions. They just receive some traffic, boom, they just round robin that across a bunch of pods. But they do keep track of the health of the pods according to various configuration options. They will remove pods that are busy or put pods back in or add new pods as they come online. This is the beginning of your communication with your workloads. There are 3 types of services. Each one contains the type that came before it. The first one is cluster IP. A cluster IP service has an address and a DNS name, and it only exists inside of the cluster. Why do you care? Well, there are things that you might need to communicate with from other things inside the cluster, but you don't need to communicate with them from outside. For example, I don't know, maybe you're running Memcache or Redis, or I don't know, Redis you might need to talk to from outside, but some resource that is consumed by other workloads inside the cluster. Create a cluster IP service for it, they'll talk to each other, and that's great. You don't have to worry about it. A node port service first creates a cluster IP service, And first of all, none of these things actually exist. They're all logical things based on rules that happen in IP tables, and they do network routing. So when I say it creates a service, it's like it's in air quotes. So it creates a cluster IP service. Then it opens a port on every node in the cluster. That port is between 30,000 and 32767. Traffic that lands on that port is directed to the cluster IP service and is in turn directed to the pods that sit behind the service. You'll use this if you have an external load balancer, for example. So you would create your node port service, and then you'd go out to your load balancer and you'd say www.myawesomecompany.com goes to all of my Kubernetes nodes on port 31658 or something like that. And the load balancer operates at layer 7, and it does the routing to layer 4, and there you go. If you have a cluster that's in a cloud provider and it knows it's in a cloud provider, and you've done all of the extra magical stuff that you need to do with the cloud provider for it to recognize that your cluster exists, hooray, all of this is done for you if you use something like EKS, you can create a load balancer service. This will create a cluster IP service, it will open up the node ports, and then it will reach out over the cloud provider's API and create a cloud load balancer. In the case of Amazon, which is where I spend most of my time, that will either be an ELB or an NLB. Okay, so traffic lands on a load balancer. Oh, it then programs the load balancer with all of the information about the hosts, the stuff that you had to do manually a minute ago. It maintains that configuration as well. So as hosts come and go, or if anything changes, Kubernetes reaches out and programs the load balancer. So you don't have to worry about it. And that's great. Traffic lands on a load balancer, goes to the hosts, and there you go. Okay. It looks like that. Layer 4 load balancing. Huzzah! Welcome to the future. But there's a problem with this. If you have a cluster that's running 1,000 websites, you don't need 1,000 ELBs. I mean, well, maybe you do. Maybe you're that big of a company. But for most of us, you don't need them. You don't need 1,000 cloud load balancers that cost $20 a month just so that you can get some traffic and route it around. Kubernetes has solved this problem for you as well. And it's called an ingress. An ingress is a layer 7 load balancer that sits on the cluster, in the cluster. Okay, so the ingress is actually a virtual thing. An ingress is the rule set that you apply to the cluster that says, hey, I want this thing to receive traffic, respond to it for this host name on this path, and send it to this service. The ingress controller hears that request on the API and configures itself to do what the request asked for. Ingress controllers are software load balancers. The one that you're most commonly going to encounter is the Nginx ingress controller, but there's also traffic, there's HA proxy, there's stuff that can do this with service mesh, there's API gateways like Kong, there are lots of things that provide ingress functionality, but you, as the operator, you just create the ingress, and the thing that does it just goes and does it for you, and you don't really care. We are using traffic today because that is the default ingress controller inside of K3s. If we had deployed RKE, it would be Nginx, but it doesn't matter. You deploy whatever ingress controller you want. And they look like this. They receive traffic, they make a decision about it. They operate at layer 7, and then they send it through to the service. Now, because they operate at layer 7, they are for HTTP resources because that's pretty much everything that happens at layer 7. If you also need something at layer 4, if, for example, you needed to punch through MQTT or MySQL or something that has its own SSL certificates and is already encrypted, something where the ingress controller can't actually see or understand the packets going on there, then you can still punch through TCP services at layer 4 in most ingress controllers. We're not going to do it today, but just so you know, like, you can do that. I happen to have an ingress controller. Sorry. I happen to have an ingress that I can show you that we can deploy. We are in the overlay directory. And my mouse is on the wrong thing again. There we go. Want to be over here. First, we start with the customization file. This is going to be our dev environment, and you can see that it's going to do the labels and stuff like that. It's going to use the ingress.yaml resource locally, in addition to using the stuff from the base directory that we were working in before, and it's only going to patch the service. It will patch it by changing it to a cluster IP. Now, what you don't know, because I forgot to show you, is we already have two services running. Ignore the Kubernetes service, that one's just there. Staging Nginx and Prod Nginx. Both of these are node port services. You can see that because they say node port. Good job. Good job us, right? You can also tell because they have a port here. So in this case, the staging environment is listening on 31810 and the production environment is listening on 31171. So if I curl the port for staging, you see hello from staging. And if I curl the port for production, you see hello from production. Now, let's look at our ingress. And you see that it has API version, kind, metadata, and spec. Spec has rules. The rules say respond to requests for this host on this path and send it to that service on that port. And that's it. Now we could send it to different services if we wanted to. You can get into a more microservices style thing where you've got different groups of pods running different pieces of your web app, and you're sending the traffic according to /store and /products and /profile or whatever. We're just going the simple route today. But then we're changing our service to a cluster IP. We will apply that with kubectl apply-k. It applied it. And now, let's see, kubectl get pods. We have 1 staging, 3 production, and 1 dev environment. If we look at our services, we have 2 node port services and 1 cluster IP service. Note that the cluster IP service does not have that high port number. This is only accessible from within the cluster. But now we have an ingress, dev demo ingress. That's the host it's going to listen to, and it is, because the ingress controller is listening on port 80 on the host itself, that's the address of the host. If I curl the actual host name, you see that what we get is our default config map telling us hello from nowhere. Right here, right now, in, ooh, wow, that 20 minutes went by fast. We've just created on a single node cluster 3 applications, development, staging, and production, using node port services and cluster IP services, using an ingress or using direct access, with 3 deployments, all from a templated system using Kustomize. And that, my friends, is Kubernetes. That's it. We're done. Well, we're not done, but we're done, kind of. Let's jump back really quick to the beginning where I showed you what you needed to know. Pods, base unit of deployment in a Kubernetes cluster, smallest thing. Learn to love them. Replica sets, learn to ignore them. Deployments, learn to understand them. Config maps, as you need them, you don't always need them. Services, expose your workloads, and ingresses provide layer 7 intelligence on how to get to HTTP workloads, which is most of what you're going to be spending your time with anyway. Now, let's jump over to the Rancher stuff, and I'll answer some questions really quick. And we're probably gonna run long again. I don't know why I don't just make this a 2-hour training. I think because fewer people would sign up. It's better to make it 90 minutes and just go for 2 hours. Let's see. My Rancher slide is really boring. It says, Rancher time. Right. I'm going to first spin up Rancher, and then while it's spinning up, we'll look at some questions. I told you about the documentation. In the documentation is Rancher 2.x and information on how to install Rancher. There are 2 ways that you can install Rancher. 1, into a Kubernetes cluster. For support, remember, Rancher is everything we do, free and open source, but we do provide support for those who want it. In order to have your environment be supported, you need to be running your Rancher server cluster inside of either K3s or RKE. The reason for that is because we build those, and so we do all the testing. We know that it's going to work there. It might work somewhere else. If you were to deploy Rancher in AKS, for example, maybe it works today. Maybe Microsoft changes something tomorrow and totally breaks it. We don't control AKS, so we can't guarantee from a support perspective if it's going to work. So install it where you're going to want to install it, whatever. Or for stuff like we're doing today, you can just launch it as a Docker container, and it contains all of the Kubernetes stuff that lives inside of it. If you want an HA Rancher environment, it gets its HA-ness from the Kubernetes cluster in which it's running. If you have an HA Kubernetes cluster, you install Rancher into it, you have an HA Rancher deployment. If you have a standalone cluster, well, guess what? If you think that you might put production workloads on the Rancher server you're playing around with, but you don't want to commit to an HA cluster today, install it into a single node cluster. It takes the same number of nodes, but you can convert your cluster, if it's K3s or RKE, you can convert it to being HA later. And, well, actually, I don't know if you can do that with K3s, but you can do that with RKE. So install it into a single node RKE cluster, and RKE can go from 1 node to 3 nodes without any change. It just becomes HA, and then you can continue doing stuff. There's no way right now to go from the Docker container version that we're going to install today to a Kubernetes deployment. You just can't. So if you start with the Docker and later you're like, this is awesome, I'm going to put production workloads on it, I want HA, you got to redo it all from scratch. Ask me how I know. So all of the instructions on how to do that are here. I happen to have a server node sitting out there just waiting for us. I'll explain this in a second. Oh, shoot, I don't actually know which version I have installed here. Docker images. I have 2.4.5. Okay. If I put the wrong thing in, it'll take like 45 minutes to download because I live in the middle of nowhere. You know, I should really have that ready to copy paste. All right, Docker run D for detach or demonize or whatever. Restart is unless stopped. The reason for that is because our upgrade and backup procedures for the standalone container require that you stop the container, make a backup, start the container, or stop it, do your upgrade, start it. If you use restart is always, then when you stop it, Docker will restart it because that's what you told us to do. And the only thing you can do is kill the container, and then you have nothing to start after your backup or nothing to roll back to if your upgrade fails. So do unless stopped. Punch through 80 and 443. And then I like to bind mount a directory on the host. I use opt rancher, and I bind that to var lib rancher, which is the persistent location inside of the container. If you don't do this, it creates a Docker volume. I find that the Docker volume is a little bit more of a pain to make backups of because there's that one directory that normal humans can't actually CD through. And so this way I can just stop the container, tar off the directory, start the container, and it makes my life easier. By now, this is probably up. And if we come over here to a browser, yeah. It comes up by default with self-signed certificates. You can also use your own certs that you can bring, either self-signed or from a private CA or a real CA. You can also have it generate certificates dynamically from Let's Encrypt. The information on how to do those things are in the documentation. It's first going to ask us to set an admin password. And once we have that set, it's going to ask us for the server URL. This is important. Downstream Kubernetes clusters have an agent that reaches back to this URL and open a WebSocket connection for communication with the Rancher server. It's theoretically possible to change this, but it's a huge pain because if your Rancher server, like the IP changes or something, you can't get to your downstream clusters to update them. So it's better to use a DNS hostname, and then you can just change that rather than an IP, and just make sure that this is something that things can connect to. So if you're deploying stuff out on Amazon, don't use an address inside your house or something like that. This is our top level cluster view. Rancher can manage hundreds of Kubernetes clusters. So all of them will appear here. When you say add cluster, you're presented with a list of options. You can deploy a hosted provider, EKS or whatever, and it will actually reach out to the cloud provider with the credentials that you give it, and it'll spin up a cluster, wire it back into Rancher, and do full lifecycle management of it. So you add and remove nodes, delete the cluster, all of that happens right here from within Rancher. You can do the same thing with infrastructure nodes. So you can, instead of spinning up a hosted cluster, you can spin up EC2 nodes, and they'll spin up. Rancher installs Docker, Rancher installs Kubernetes, Rancher wires them back to the Rancher server cluster, and you still get all of your full lifecycle management. If you do provisioning via some other means, Ansible, Puppet, Chef, Cloud Init, Terraform, shell scripts, whatever, if you select this option, Rancher will give you a Docker run command that you can apply to those nodes. That is unique to this cluster, so you can just put that at the end of your provisioning, and all you need to do is provision your nodes, patch them, do whatever you need to do, install Docker, and then run that Docker run command, and those nodes will have RKE installed, and they'll be wired back into the cluster. If you need to add more nodes, you just do that, new nodes join the cluster. This is actually my preferred way of doing it. Even out in EC2, I do this with auto-scaling groups. And if you have a Kubernetes cluster already running out there in the wild, you can just import it. And that's what we're going to do with our K3s cluster. Because our Rancher server does not use real certificates, we need to use this bottom option because kubectl will not talk to, I know I said I was gonna take questions, I'm still gonna take questions. Hang on. kubectl will not talk to something that uses self-signed certs. So instead, you have to run this, and I always have to run it twice in my house. I don't know why. And that pulls down some manifests, applies them to the cluster, and now the cluster is going to install its agent. And while it's doing that, let's look at questions. Oh, we have a bunch of them. Okay. If we go long today, and the likelihood of us going long is pretty much close to 100%. This is being recorded. You will get an email afterwards that has a link to the slides, and I'm going to post the video up on YouTube. It takes me about a day to get it edited and posted, and so you'll get that, and you'll be able to come back and watch anything that you missed if you have to leave in 15 minutes. Otherwise, if you can stay, well, stay, because this is what I do on Thursdays. Let's see, what do we got? All right, Alejandro wants to know how it is that my console predicts my commands. That's fish. The fish shell has history based on directory context. So it knows the commands that I've typed when I was in that directory, and it makes suggestions. I also have it bound to FZF, so I can do Control R and do like fuzzy logic searching. Fish is an amazing shell. Okay, Neil says, when you upgrade a database pod and that database used persistent storage, and then 2 days later you want to roll back the database, what happens to the persistent storage? Now it has all of its tables updated with 2 days of data. You're absolutely right. When you're looking at how to do things in Kubernetes, consider how you would do them in the real world. All you're doing is the same thing. It's just instead of using servers, you're using pods. You wouldn't update your database and then 2 days later reinstall the old version. If you have a problem that you don't discover for 2 days, then your restore process is going to be restoring the data as well. For that reason, in the case of databases, you want to make sure that you have a backup of whatever before you do the upgrade that you can roll back to. Have some procedure for testing so you'll know right away if there was a problem and you can just roll back to it. But things happen. Test your upgrade procedure in a dev environment. That's what most people do. They have a lab environment or a staging environment where they put those changes and then hammer on them with QA to make sure that there's no problem. Or worst case scenario, you lost 2 days of data. That sucks. So ingress controllers are not a Kubernetes resource, they are external. No, that's a question from Steven. They are a Kubernetes resource, but you don't ever talk to the ingress controller. Oh, I never switched back to my browser to show you the actual thing after that. Okay. I see on my screen what I'm actually showing you guys, and I did click back to terminal. Slides, browser, terminal. There we go. Sorry, I don't think you actually lost anything because mostly it was just my hands gesturing. If we look at the kube-system namespace, I don't talk about namespaces much in this class. You'll see that there's actually, in our case, there's traffic. That is the ingress controller. We just don't ever talk to it. We create ingresses. The ingress controller hears that virtual thing that we created in the API, and then, excuse me, it configures itself to do what we asked it to do. Ramesh says, finally, Rancher. uh, okay. Ganasan poses an interesting question. Ganasan, I would like for you to find me on the Rancher user Slack after this, and I'll work with you directly on this. But he asks a question about security and how we handle stuff. If there is a CVE in upstream Kubernetes, well, certainly there's a CVE in ours. We have a section in the docs under security. Rancher CVEs and resolutions, and this probably has a link to where you can report CVEs. No, okay, so it's on the main page. We respond to these. If it's in our stuff, we fix it as quickly as we possibly can. If it's upstream, then depending on the severity of it, we might patch it locally until upstream can get a patch, since ultimately we're responsible for upstream Kubernetes. That's like, we don't control how fast they patch things. So there is a place on our main website, not on the docs page, to report those things properly. I don't know what the right word is. And we will issue patch releases and updates to fix them. Okay, that's, oh, Sumedh, we have one more question. Will be advanced course after this webinar. We have master classes. The master classes are not advanced Kubernetes stuff, but they cover specific things that you might want to do, like how to do persistent storage or how to do this or that. You can find more information about our master classes on the main Rancher website under training or events or resources or something like that. Okay, so back to Rancher. The cluster's up, but at the global level, there's some stuff that I want to just run through really quick. If there are other infrastructure or cluster providers that you use that you didn't see in that list when we deployed the cluster, you can either activate them over here, or you can add node and cluster drivers. These are just Docker machine drivers for the node drivers. And so you can add them yourself and you can deploy wherever you want. If you have Helm catalogs, Rancher has an app catalog interface that you'll see in a minute for Helm apps, which are Helm is the package manager for Kubernetes. There used to be a main central repo for Helm charts, and more people are building their own repos. So if you find somebody who's like, oh yeah, just connect to our Helm repo, you can add those catalogs here. And you can add them either at the global level, or you can add them at the cluster level, or you can add them at the project level. And we'll talk about projects when we get into the cluster in just a second. Also at the global level, you can bind Rancher to a backend identity provider. This is critical for enterprise environments because Kubernetes is so prolific. If you work in an ops department and you have teams of people doing stuff with Kubernetes, they're going to have Kubernetes all over. They're going to have it in Amazon. They're going to have it in Google. They're going to have it under their desk. They're going to have it at their mom's house. Like, you can get your Kubernetes from everywhere. The problem for you is that you then are in the business of creating access credentials in all of these locations and maintaining access credentials in all of these locations. And that's a recipe for disaster. Because if somebody leaves the organization, you have to wonder, what did they have access to? Did I clear all of their accesses? Who knows? When you connect Rancher to a backend identity provider, it becomes an authentication proxy for all of the downstream clusters. You have multiple clusters and you say, okay, this team has this level of access for this cluster over here, and that team for that, groups for that cluster over there. Somebody joins the organization, you put them in the group, they instantly get access to stuff. They leave the organization, you disable their account, they lose access to it. So much better for security. Also at the global level, we have pod security policies, and there's a new thing that's replacing pod security policies, and I keep forgetting its name. Anyway, whatever it is, it's coming soon in 2.5. Otherwise, back over here, you see that we have our cluster, and now we see projects. Very quickly, namespaces in Kubernetes are collections, they're logical collections of resources within which each name must be unique. That makes sense, right? You can't have two deployments called Nginx, because which one are you telling Kubernetes to change? So you can't have website twice, but you could have two namespaces, a production namespace and a staging namespace. And inside of each of them, you could have a deployment called website, because namespaces are logical groups of objects. The namespace is the boundary at which role-based access control is applied. So you have user accounts and they have access to a namespace, and that gives them access to the things under that namespace according to the permissions that they've been assigned. But remember a second ago when I was talking about identity providers, if you have thousands of clusters with tens of thousands of namespaces, you don't want to, or even one cluster with hundreds of namespaces, you don't want to be like adding configuration to every single namespace when somebody joins the organization. So Rancher collects namespaces into projects, and you can assign role-based access control to a project, and it transfers down to all namespaces that are underneath it. By default in a Kubernetes cluster, you get two namespaces, kube system, which has system level stuff that you should just leave alone, and default, which has whatever else you want to do with it. But you can create any other namespace that you want. Rancher gives you two projects, the system project, which has kube system and some Rancher namespaces that we create, and then the default project, which has the default namespace. Inside of the default project, you see the workloads that we already created and were running. Now, since we're almost out of time, I just want to show, not out of time, but since some people are going to drop off here in 5 minutes, and actually I have like 5 slides to run at the end that I'm going to step over and run, and then we're going to come back to this just so that people see the last little bits. We're going to run a demo workload here, and this is going to be Monakas, Rancher demo. We're going to tell it that it listens on 8080 with a cluster IP service, and we're going to set an environment variable of cow color is yellow. And I'm going to just kick that off. And then real quick, I'm just going to jump back to the closing slides, and then we'll come back and we'll finish with the Rancher stuff. If you want to know more about how to do stuff with Rancher, I built the Rancher Academy. It is a comprehensive course in deploying Rancher in standalone and HA environments, and then how to use it to deploy and manage Kubernetes clusters. It's about 5 weeks, about 25 hours worth of time. It has labs and follow along exercises, and it ends with a certification that is extremely valuable, that shows your peers and your employers or prospective employers that you have been certified or certificated by Rancher, that we have approved that you have the skills to manage Rancher in production. It is hugely popular. We had more than 1,000 signups on the first day. We have more than 7,000 now. It just launched in the middle of May. We've issued close to 1,000 certificates already. Remember that you have the Rancher user Slack. It's a great resource. I am there as Adrian. You can always talk to me. And since I'm the director of community, I'm here to talk to you. I'm here to help you be successful. That's me again. You'll get these slides at the end. And so there you go. Now let's jump back over to Rancher. That's for everybody who has to leave. The rest of you, we still got some time. Let's actually jump over to the terminal really quick and just delete the development environment that I created, because I want to reuse that host's name. Hey, poof, look at that, it's gone. Now, Rancher doesn't hide anything from you. You saw how easy it was for me to deploy something. And if I expand some of these options, you see that, oh, okay, so we use a deployment, but we could have run a daemon set, a stateful set, a cron job, or a job. We have a bunch of options here for things that are commonly used. And then down here on the right, there's a link for show advanced options that opens up a whole bunch more stuff that gives you form-based configuration over all sorts of things for how your workloads run. The idea here is that somebody can get in and start using Kubernetes without having to spend the year that it takes to learn everything about it. If you know how containers work and you know what you want to deploy, you can figure this stuff out. And especially after going through today's class, you have everything that you need to just get busy. We had an ingress that I just deleted. So for our new workload, let's create one. We'll call this demo. And I want this to be that same host name. So I'll specify that. We'll change this from a workload to a service. We want to route / to the demo workload. It picks up 8080. We don't have any SSL certificates or anything, so we'll just let that go. And now if we click that, we're taken to our app. This app is a quick little demonstration that shows how the load balancing works. So you have the ingress that we're hitting from the outside, routing to the cluster IP service, and then you can see it's doing round robin load balancing across those 3 replicas. But imagine that we get a call and our client that we built this app for is freaking out because their boss is allergic to the color yellow. We can come in and we can either come in and edit the YAML directly, so it shows up in here, or if we're not comfortable with YAML or we just think that it's ugly, well, we can come in and we can just edit the service. We know that the environment variable controls that, so we'll just say save, and Kubernetes will start doing a rolling update of the application. In a minute, if we hang out here, we'll see the pink cows start rolling in, and in another few seconds after that, the yellow cows will go away. You can import YAML. The services were created for us because we specified that, so that's just a little light workload thing. You have volumes here for persistent storage. This is just standard Kubernetes stuff. There's not really a lot special going on here. Where Rancher begins to shine is with the stuff that I talked about in the beginning slides, where I said that you need something that does the heavy lifting of the additional value that you can get from using a Kubernetes cluster. So for example, Rancher ships with a bunch of alerts that you just need to create notifiers for. So you come out here to the global cluster level, and you come over here to notifiers, and you can create notifiers that use Slack, email, PagerDuty, arbitrary webhooks, or WeChat. Once you have those set up, then you can do cluster level alerts or project level alerts. Cluster level alerts will send alerts for things that are wrong with the actual cluster infrastructure. And project level alerts send alerts for things that are wrong with the workloads in the project. You can also do log shipping to any of these providers, and you can separate that out at the cluster level and at the project level. So I, as a cluster admin, might want everything going to Elasticsearch, but you, as the developer who works on a particular project, well, you might want everything going to Kafka. So that's great. We get them both. The default monitoring is pretty basic. And if you have a little bit of oomph on your nodes, more than what I have on this little node that I use for the example, up here, you can't see it on the screen, but you can enable monitoring to see live metrics. This will install Prometheus and Grafana into the cluster and begin tracking metrics for the cluster and its projects with dashboards automatically created and visible according to the access permissions that individuals have. It's a very long-winded way of saying if you can only see what's running in one project, you can only see metrics for what's running in that project. But if I'm a cluster admin, I can see cluster metrics as well as metrics for all of the projects. And as a global admin, you can see metrics for each of the clusters and everything running inside of them. The granularity of permissions from Kubernetes role-based access control is not just fantastic, but is made manageable by using a tool like Rancher. Back in my project, what else do we have down here? If you don't have a CI/CD pipeline system already running somewhere, but you want to start using one, well, we make it easy for you. Just point Rancher at your repos, and yeah, you can start doing builds and deploys based on code pushes to your repositories. This will be enhanced in Rancher 2.5 to include GitOps style workflows as well. The app catalog. I briefly touched on this when I was talking about apps earlier. Helm charts are a way for me to package up an application and give it to you. And you can just say, Helm, install Adrian's app, and it will install all of the pods according to the configuration and the databases and whatever it is to make the app work. And it allows you to override individual configuration parameters using what's called, well, a file called values.yaml. So you set key value pairs. If you wanted to deploy something, you would have to know what all of those key value pairs are. And if you're new to Kubernetes, you can't see them, but those are keys on the left and values on the right. I don't know why they're in green on black. As a new user of Kubernetes, this might be daunting. Well, Rancher apps are a way of taking a Helm chart and adding a little bit of extra configuration to it so that it becomes form-based. And now somebody can come in and just look at these values, look at these parameters, and set them because they make sense. So service type, oh, well, there's the available options. Do I want this? No. Do I want persistent volumes? Yes. Okay. Here's some other options. And when all is done, those variables are substituted into all of these manifests for you. And this is applied to the cluster. The graphical way of doing it makes it a lot easier. Under the apps screen, you'll see what you have deployed. And then when there are updates available, there'll be a little yellow badge that says update available, and you go through and you do your rolling upgrades of your applications. The story I like to give is, imagine I'm a developer and I'm building an app and the app needs to talk to a Hadoop cluster, but I don't really know how to deploy Hadoop, let alone in containers or with Kubernetes, nor do I really care because I just want to use it. I don't want to learn how to do all of this other stuff. So if my company is using Rancher, I can come in here and I can say launch, and I can just scroll down, or I can type Hadoop, select that, and I'm presented with this form, and I can, okay, so what resources do I need? Do I want a persistent volume? No, because this is just going to be for today. Specify a host name. Okay, great. And then I'll say launch. And in a few minutes, it will build for me a 5-node replicated Hadoop cluster, and it will hand me back an endpoint that I can put into my app. And literally in less than 10 minutes, I can get back to work actually using the tool instead of spending hours figuring stuff out and probably still doing it wrong. Everything that Rancher does is built with that type of simplicity in mind. The last thing that I want to show you before we take any final questions and call it a day is back here at the cluster global level, the top level. You see there's a button here for launch kube control in the top right. This is an inline shell for running one-off kubectl commands. So that's cool. It's super small print, but whatever. Or you can get this kubeconfig file. And this is what I told you allows Rancher to be the authentication proxy. Users log into Rancher, and if you don't have a backend identity provider like Active Directory, actually out at the global level, you can directly configure users and groups within Rancher. So you can get the benefit even if you're not using some third-party external solution. Oh, that totally derailed whatever I was talking about. Yes, the kubeconfig. So take this kubeconfig file, put it locally on your machine. In fact, let's just do this. We'll copy this to the clipboard. We'll jump over here to terminal. Come back out. We'll move my kubeconfig to kubeconfig.old. And now if I run kubectl get nodes, it looks exactly the same, but now it's actually going through the Rancher server. You can see that there, not directly to the cluster. Remember, the cluster is on training-A and the server is on training-S. My level of access, because I'm an admin, is admin level, but this will deliver just the level of access to the cluster that that user has. If you give somebody read-only access to the cluster, then when they connect with kubeconfig or kubecontrol, that's all they're gonna get. Super cool. Okay. Not as bad as we normally are as far as overtime. Let's take questions. Rohit says, in K3s, when we enable firewall D, name resolution doesn't work with the container. What's the DNS port used? Is enabling port 53 and firewall D does not help. That is one of those questions that's too specific for this class. Go to the Rancher user Slack, join the K3s channel, and ask it there, and somebody will be able to give you an answer. Dash says, in a world of Rancher and ADFS auth where multiple users are using the cluster, how can we tell which user deployed which workload? Audit logging. You can enable audit logging for the cluster itself, and it will tell you who did what. There's a whole section in our documentation on how to do that. That's actually part of the security stuff. Let me show you that. We have a whole section down here on how to do CIS benchmark scanning from directly within Rancher of currently just RKE clusters, but in 2.5 we'll support additional clusters. This allows you to scan your clusters for best practices according to the CIS benchmarks, and then it gives you instructions on remediation to solve things that it finds. There's also the Rancher hardening guide for the various versions of Rancher that you see there, and this tells you exactly what to do on your hosts and within the Kubernetes config to lock that stuff down. So the last question was actually Rohit following up on the first question saying, correct me if I'm wrong. So you're not wrong. I'm sure that there's something that Firewall D is doing. I don't have an answer for you. If I did, I would just tell you. So yeah, go to the K3s chat. All right, we still have 23 of the 35 people who were here a little while ago. Everybody else had a meeting at 2:30. So yeah, that's basically it. But for those of you who stayed, I also would like to show you. This is the Academy. I already told you about it. I'm always in the Academy channel in the Rancher user Slack, and there's about 500 people in that channel. So I'm there to help you as you go through the Academy with questions that you might have. But we also have lots of other graduates at the Academy who hang out there and help people. I run most of what goes up on the Rancher YouTube channel. There you'll find our online trainings like this one. You'll find our master classes, you'll find meetups and webinars and various other things that we do. So there's a vast amount of information there for your education. And then I also run my own YouTube channel where I have content about Rancher as well as content about pretty much anything else cloud native that interests me. And in fact, just this week, I don't even have it in that slide, just this week I launched the Coffee and Cloud Native live stream, which is a live stream that I'm doing every morning at 7:30 my time, which is currently the same as Eastern time, for half an hour, where I talk about anything interesting that happened yesterday in the world of cloud native. So if you want to tune into this, we talk about new releases of things, cool tools. We have a section called Tool of the Day where we showcase some cool thing about Kubernetes or whatever that is a cool command line or web-based tool that you can use to make your life easier. It's fun, it's lighthearted, it's a great way to start your day. So please join me there. And there's information in those videos about how you can post content ideas if there's things that you'd like me to cover, or if you have suggestions for tools of the day or whatever. It's a community-based initiative. All right, we have no more questions. Thank you very much for staying late. Thank you very much for coming at all. I really like doing these things, but they're a lot harder to do when nobody's here. So, so I hope you had fun. I hope to see you somewhere at an event, in the Academy, in Slack. Have a great day. Keep learning.